Okay, just a little review about local and global extrema. So we've done this before, but if we have a graph that's going, something like this, we say, well, this is like a local max and a local min, right? So local max, local min, or they're also called relative max and relative min. This particular graph would not have any global extrema, and the other term for global is absolute. So there's no absolute maximum or absolute minimum for that graph. Now, one thing that we want to point out, we haven't mentioned this before, you could have a graph that goes something like this. That would be an even polynomial function. And you can see that you have global maximum. So by global or absolute, we mean that's the maximum point, of all. I'm assuming those are the same, but this one looks a little bit higher, so that would be like the global max. And then if you had a graph going like this, you'd have a global min right there, or the absolute minimum point for the whole graph. And this is also an even function. Notice that you can only have a global max or a global min on even functions, okay? So just pointing that out. Okay, now we're going to do this problem where we're going to kind of put it together and apply some of what we're learning. An open top box is to be constructed by cutting out squares from each corner of a 14 by 20 centimeter sheet of plastic. Okay, so let's draw a rectangle, a sheet of plastic. So we're going to say this is 14 centimeters and this is 20 centimeters. And what we're going to do is we're going to cut a box that's the same dimension. It's square box, square corner. We're going to cut those out of each corner. And then what we're going to do is we're going to fold up these sides. And it's going to make a three-dimensional box. I don't know if you've ever done that before. I've done it before. You can get a box like that, okay? And then what we want to do is we want to find the size of squares that should be cut out to maximize the volume. So we want this to have the most volume possible. Well, we have to know volume then. Volume is length times width times height. We're trying to figure out how much to cut out. So we're going to say that this square here is W by W. We're just going to use W, okay? And that's for each of them. Well, then that means that this side here is 14 minus 2W. So my, width is going to be 14 minus 2W. My length, this side here, is going to be 20 minus 2W. Now, why 2W? Because you're taking out W here and here. Okay, same for the 14. Okay, so my length is 20 minus 2W. So that gives me then a volume formula of the length, 20 minus 2W, times the width, well, I don't want the width there, but that's okay, I'll fix it in a minute, times the height. Oh, no. Shoot. W doesn't stand for width in my little thing here. Okay, so my width was, I better write this out, length, width, and this is width. This is called the height, but that's my W. I wish it were an H. I just wanted it to be clearer, and that's what the book used in case you reference this later. Okay, so 14 minus 2W, I would have used H for height. Okay, and then W. All right, we can multiply that out. What do we get? What's 20 times 14? 280. And then you're going to get minus 40W minus 28W and plus 4W squared. So I'm just multiplying the binomials and then times W. So I'm going to get the volume in terms of W. I get, 4W cubed. I'm going to rearrange it too. minus, let's see, what's 40 and 28? 68W squared. I'm distributing the W at the same time. Probably shouldn't do too many things at once. Plus 280W. But just trust me, that's where the equation comes from. So what do we know? Well, we know it's a cubic equation, right? So if I want to look at the graph, now we're understanding where the equation is coming from the picture and the diagram and the sheet of plastic and making the box. Okay, now we're interested in what does that graph do? Well, let's go back to our factored form. Well, let's factor it because we'll factor it better. Does 4 go into all of them? I think so. Okay, so let's factor out a 4W. And then that's going to give us W squared minus 17W plus 70, right? Okay, now can I factor that binomial or that trinomial in there? I think I can. So 7 and 10 are going to work. W minus 7 and W minus 10. So you could use some factoring techniques there. Now, why do I want the factored form? This is great up here because it tells us the leading term, tells us our end behavior, tells us how many turning points we have and stuff like that. This is great here because it tells us our intercepts, right? Okay, so I'm going to make a graph, little grid here. I don't really have to worry about the negative quadrants because I'm not going to have a negative length or height or width, whichever one you want to call it, but a negative, this isn't going to be negative that I'm cutting out. Okay, so where are those x-intercepts? Let's count this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have an intercept at 0. Let's look at the x-intercepts. 0, 7, and 10. So 1 here, and I think I counted 7. 1, 2, 3, 4, 5, 6, 7, and 10. Okay, what do we know about our end behavior? Our leading term is 4, right? And it's cubic, so it's going to be going down to the left and up to the right. Okay, so we know it's going to be, all of these have multiplicities of 1, right? So they're going to be crossing, so it's going to come up here, and it's going to do something. At some point, it's got to turn and come back down, and then it's going to do something like that, okay? Well, it doesn't make any sense to be 0, right? Because you're not going to cut a 0 length out. And it doesn't make any sense to cut out 10 because that would take up your whole side here if you cut out 10 centimeters. Okay, so, and we don't want a negative volume. Okay, so remember this is volume based on W. We want the highest point here, right? Okay, so my graph probably isn't great. I could go to Desmos and get a better graph. But let's say I just want to, figure this out, like where would it be the highest? Because I don't know that that's turning right there. But what I could do is I could make a table of values. Okay, so let's go back to our equation. Which one do I want? I'm going to take this equation, I'm going to write it down here. Let's see. It was f of w equals 4w cubed minus 68w squared plus 280, right? Okay. And then what we can do is simply make a table of values here and put in numbers. So I'm going to get a calculator to do this, but I'm going to find, and I'm going to make it horizontally so it fits. A lot of times I notice the book does that. But we know our global, or not our global, but our local max is somewhere between 1 and 7. So let's just see what happens. We'll have W and we'll have F of W. And we're going to try 1, 2, 3, 4, 5, 6, and 7. And then we'll just see what happens. Okay, actually we know what happens at 7. It's 0. Okay, so we don't want 0 volume. Okay, so we're going to take in our calculator and we're going to just plug in 1. And what will we get? Well, that'll be an easy one. 4 minus 68 plus 280. And that's going to be a volume of 216. So 216 cubic centimeters is what we're on. Okay, so now I want to do F of 2. So what I'm putting in my calculator is 4 times 2 cubed minus 68 times 2 squared plus 280. So I'm going to stop the video so you don't have to hear me punching it in, but you can do that on your own calculator and we're going to get an output. Oops, I made a little mistake. Okay, so let me take out that 216. I left out a W. I don't know how I did that. But that should have a W in it. Okay, so that's going to make it just, whoops, won't be W there. It'll be a 2. Okay, so that's going to make things a little bit different. So let me redo that number 1 then. I'm still going to have 4 minus 68. Maybe it doesn't make this one different. Plus 280. No, this one's still 216. Okay, but I still need that W. Okay, so now I'm going to evaluate over here. And I'm getting 320. Okay, now I'm going to evaluate at F of 3. I have to put that in my calculator, which is going to take me a minute. And you can play the game along. Put in 3 for W. Well, you could have played along, but I wrote a 3, a cube here when I meant a 2. Hopefully you caught that. I got 336, which kind of surprises me. All right, let's try F of 4. This time I'll be more careful. 4 times 4 cubed minus 68 times 4 squared plus 280 times 4. And I get 288. Now, here's where we can make some conclusions. Notice that, I'm kind of down here on the end of the screen here, but it was 216, right? Then it went up to 320. This is volume we're calculating. Then it went up to 336, and now it's on its way back down, 288. So somewhere between, we don't know that it's a maximum at 3, because it could be going up a little bit more and then start to coming down, but it's somewhere between 2 and 4. So somewhere between 2 and 4, there's going to be a maximum. And we just don't know exactly where the peak is. If you put it in Desmos, you could trace that and actually find where it is. But somewhere between 2 and 4, there's going to be a maximum volume. Okay. And that's really about all we're going to do with this. To actually get it accurate, you'd have to use a graphing utility or Desmos.